Hi viewers, welcome to our channel Kavithashok Educational and Motivational channel. Right. Permutations when repetitions are allowed. In the previous classes, we discussed the problems when the repetition is not allowed. Now, if the repetitions are allowed, then how the problems will change? Let's look at here. Let n and r be positive integers. If the repetitions of things is allowed, then the number of permutations of n dissimilar things taken r at a time is n power r. Right. Previously, we discussed about NPR. Now it will become n power r. How it converted once we will discuss. Look at here. N dissimilar things are there. We want r number of things at a time. N dissimilar things are there. We want r number of things at a time. Right. First, take r number of things. 1, 2, 3, 4, so on. This is the rth place. First place, second place, third place, fourth place, and this is rth place. When we fill up the first place, we have n choices. So n number of ways we can fill up. Right. So we can fill up in n number of ways. While filling the second blank place, we have how many choices? Previously, it is n minus 1. But here, when the repetition is allowed, again we will take the same term here also. So that's why again we have n number of terms, n number of choices. For the third also n number of choices. For the fourth also n number of choices. For the r also n number of choices. So this is by fundamental principle, the number of arrangements is equal to n into n into n into n into so on n. How many times? R times. How many times? R times. So then look at it. N into n. If 2 times are there, it will be n squared. N into n into n. If 3 times are there, it will be n cube. In the same manner, n so on r times are there. So then automatically what it will become? N to the power of r. Instead of getting NPR, here we can get n power r. We will take one example and then it is easy for us how it will become n power r. Look at here now. Suppose we have 3 numbers. 1, 2, 3. Okay. We want to write 2-digit numbers. First, if you take 1, 2 here, we will take 1, 2 once, 1, 3 once, and 2, 3 once. Okay, 2 numbers. Now the thing is here, repetition is allowed. So repetition is allowed is there now. So that's why we will take 1, 1, 2, 1, 2. Previously, we have only 1, 2 and 2, 1. There, repetition is not allowed. Here, repetition is allowed. That's why we are taking 1 2 times and 2 also 2 times. The same manner. This is 11. 11 is already there. So, we will write 13. Next, 31 and 33. We will write 11 also. Here, already 11 is there. So, that's why we are not writing that one. Next, 2, 3. 2, 2 is already there. No need to write. So, 23, 32 and 33. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at here. One is repeated. Yes, 33 is already there. No need to write this one. So, 4, 3, 7 to 9. 9. We can write 9 as 3 square. Look at here now. 3 number of things. That is nothing but n. 2 digit numbers. That is nothing but r. So, we can get n to the power of r. In the same manner, if you take the things are not repeated, just we can get NPR. Means n power r contains all the terms, including with NPR. NPR form is n and non-repeated. Repeated terms also it contains. That is a n power r. Is it clear now? If repetition is not allowed, it will become NPR. If repetition is allowed, that is n power r. If suppose in these things, total 9 things are given, in these things, at least At least one thing is repeated. At least one thing is repeated. In the sense here, look at here now. This is repeated. This is repeated. This is repeated. Okay. 1, 2, 3. 3 means, so in the total 9 is there, just we are subtracting 3. Only 6 things are there which is not repeated. This is at least one thing is repeated. At least one thing is repeated means unrepeated terms we have to remove. Unrepeated terms are 6. But we can get here 3 repeated terms. What is it? 1, 1, 2, 2, 3. So, if at least one thing is repeated in the sense, total number of repeated things minus non-repeated things. Non-repeated things is this one. Repeated things is this one. If we subtract n power r minus npr, we can get at least one thing is repeated. Is it clear? Like this, we can calculate the answers. Now, we will discuss one important concept, palindrome. From this concept, we may expect 2 marks question. Not only for the 2 marks question, it is also important for the competitive exams like MSET and JEE mains. Look at here now. Palindrome. Palindrome means, look at here now. ATTA is there. Atta. If you read from left to right, ATTA only. If we read from right to left, ATTA. So, if we pronounce a word from left to right or right to left, there will not be any change. Look at here now. 1, 2, 3, 2, 1. 1, 2, 3, 2, 1. Or from right, 1, 2, 3, 2, 1. So, in the same manner, we can get the same thing from left to right and right to left. There is no change in the letter or the number. Those numbers are called palindromes. So, if the palindromes concept is there, then how can we solve the problem? That is very important. So, look at here. A number or a word, whatever it may be. It may be a number, it may be a word. Reads same either from left to right or from right to left is called a palindromes. So, these type of words or the numbers are called palindromes. So, some examples are there. We took atta, 1, 2, 3, 2, 1. So, rotor, same, R-O-T-O-R, R-O-T-O-R. So, that is also a palindrome. 1, 2, 0, 0, 2, 1, 1, 2, 0, 0, 2, 1, like this here. So, these numbers or the words are called palindromes. If palindrome concept is there, how can you arrange? So, that is very important. So, what is given here? The number of palindromes with R distinct letters that can be formed using giving n distinct letters is n to the power of r by 2 if r is even, n to the power of r plus 1 by 2 if r is odd. Suppose we have n things like this here. We have n things. We want to construct a 4-letter word. I am taking n is equal to 4. Why? Because that is even. N is equal to 4, right? 4-letter word. 1, 2, 3, 4, right? To fill up this, we have how many choices? N choices. Whatever it may be, the letter we are filling here, automatically it is filled by the last place. Why? Because A is filling in the sense here, the last place also contains A only. Why? Because that is a palindrome. So, we filled this one in the sense, automatically it is filled in this place. Okay. Now, to fill up the second place, how many choices we have? Again, n choices. Why? Because repetition is allowed. So, then again n, we filling the second place in the sense, automatically the third place also filled. Like this here, T and T. If we arrange this one, automatically it will be arranged. If we arrange this one, automatically this will be arranged. So, there is no separation to arrange the remaining things. So, how much we can get here? N square. N into n, we can get n square by fundamental principle. Look at here now. N square we can get n to the power of 4 by 2. That is nothing but n to the power of 4. In the sense, 4-letter word. 4-letter word by 2. N to the power of r by 2, like this here. If n is even, 4 words are there, we can arrange in n to the power of r by 2 words, means n square ways. If suppose r is odd, then take 5 places, 1, 2, 3, 4, 5 places. To fill up the first one, we have how many choices? Total n choices. Automatically it will be filled like this here. 1 and 1, that is filled only. If we want to fill up the second place, then automatically this place is also filled. What about the remaining? For the remaining also we have the same choices, n choices only. Is it clear now? In the previous even letter words, there is no single place. But here, this is filled in the sense, this is also filled. This is filled in the sense, this is also filled. For the remaining also, we have the same choices. By fundamental principle, again, we can get n into n into n in the sense here, n cube. So we can write this as n to the power of, we can get, already 5 is n, 5 plus 1 by 2. 6 by 2 is nothing but 3. That means what? N to the power of r is equal to how much we take here? 5 places. 1, 2, 3, 4, 5. So r value is equal to 5. In the place of 5, we will replace r plus 1 by 2. This is n to the power of r by 2 and this is n to the power of r plus 1 by 2. If n is even and n is odd. Is it clear now? Like this we have to fill up to find out the palindrome concept. Now we will discuss about the problems. Right. Discuss a 2 marks question. Find the number of 4-letter words. We want the 4-letter words here. That can be formed using the letters of the word piston, in which at least one letter is repeated. So this is very important. At least one letter is repeated. We also discussed the concept of at least one letter is repeated. Look at here now. Piston, it contains 1, 2, 3, 4, 5, 6 letters. N is equal to 6. We want 4-letter words. So R is equal to 4 here. At least one letter is repeated in the sense here. From total number of arrangements, we have to subtract those arrangements which are not repeated. Is it clear? In the previous case, we discussed now. Suppose 1, 2 is there, we will write 1, 1, 1, 2, 2, 1, 2, 2. When the repetition is allowed, we can get this. When the repetition is not allowed, so we have to remove this one and this one. These two are nothing but here the permutations without arrangements, without repetition. The total, the permutation with repetitions. So, at least one letter is repeated in the sense permutations, number of permutations with repetition, number of permutations with repetition minus number of permutations without repetition. Number of permutations without repetition. So then we already know here 4-letter word in the sense 1, 2, 3, 4. Okay. Minus again 4-letter word in the sense 1, 2, 3, 4. Right. Number of permutations when repetition is allowed in the sense, to fill up the first place we have 6 choices. To fill up the second place also 6 choices. To fill up the third also 6 choices. To fill up the fourth also 6 choices. Number of permutations when repetition is not allowed in the sense, we have to fill up without repetition. Without repetition then said 4 blank places we can fill by using 6 dissimilar things is nothing but 6p4. We already know this one. This is nothing but 6 power 4. 6 into 6 into 6. This is nothing but the formula of n power r minus npr. N power r minus npr. So this is 6 power 4 minus 6p4. In the exams, if you write like this, there is no need to write the formula. If you write the formula, there is no need to write this one. Okay. For your understanding, I explained how we can get this one. So 6 power 4 minus 6p4. 6 power 4 in the sense 36 is 1296. Minus 6p4 in the sense 6 into 5 into 4 into 3. 4 in the sense 1, 2, 3, 4. 30, 120, 360. Okay. 6 minus 0 is 6. 9 minus 6 is 3. 12 minus 3 is 9. 936. So, we can get 936 4-letter words which contain at least one letter is repeated. So, like this we can solve the problem. Right. Look at here now. We have 3 questions here. 3 important questions. A number lock has 3 rings. Each ring has 9 digits. 1, 2, 3, 4 up to 9. Find the maximum number of unsuccessful attempts that can be made by a person Who tries to open the lock without knowing the key code? So that is our first question here. We will solve the first one. Look at it now. 3 rings are there. Suppose the number lock is like this here. It has 3 rings. First ring, the second ring. These are the rings. First ring, second ring, third ring. Okay. Each ring has 9 digits. So each ring has 1, 2, 3 up to 9. 1, 2, 3 up to 9. 1, 2, 3 up to 9. These are the rings. We will ring like this here. Move like this. Right. Find the maximum number of unsuccessful attempts. Unsuccessful in the sense the lock will not be open. Successful in the sense the lock will open. For a lock we have only one code. That is only the correct code. If we know the correct code, directly we will open the ring. But here we don't know the key code. So that's why we are having unsuccessful attempts. So 3 rings are there. We will move this first ring in 9 times. Second ring is also in 9 times. Third ring is also in 9 times. So maximum we can move these rings in 9 into 9 into 9. 9 cube times. But in this here, one successful attempt is there. If we know the key code as 1, 4, 3, suppose. This is only the correct code. These are the total successful codes. Total number of codes. In that, the correct code is 143. If we know this one, directly we will open. But we don't know. That's why we tried like this. In that, if in this 9 cube in the sense here, 81 into 9. And 1 to 9. 729 attempts. One of the attempt is 143. If we subtract this one attempt, then the remaining total are unsuccessful only. So that's why 729 minus 1. This is equal to 728. Is it clear now? We have total 9 cube choices. In this one successful attempt is there. We want the number of unsuccessful attempts. So that's why simply we subtract the successful attempt, then we can get 728. Like this we can solve. Now go for the second. What it says here? Find the number of 6 and 7 letter palindromes that can be formed using the letters of the word equation. First equation in the sense 1, 2, 3, 4, 5, 6, 7, 8. N is equal to 8 is there here. First we want 6. 6 in the sense R value 6, that is even. Okay. First take 6 places. 1, 2, 3, 4, 5, 6. To fill up the first place, we have 8 choices. If we fill up this one in the sense, automatically this is also filled. To fill up the second one also, we have the same 8 choices. Automatically this is also filled. To fill up the third one also, we have the same choices, 8 choices. It is also filled. Now the answer is 8 into 8 into 8. This is 8 cube. We already have the formula of n power r. Where n is even, we have n power r formula. By directly writing the formula also, we can substitute like this. If we write like this, we understand the total problem. What is the concept behind that? Is it clear now? Next. In this, one more question is there now. This is second and first one. The second. Okay, we will take it like this here. What is this here? 7. 7 in the sense r equal to 7. This is r. Then 1, 2, 3, 4, 5, 6, 7. To fill up the first place, we have how many choices? 8 choices. Automatically this is also filled. This is also filled in the sense these two filled. For the third also, these two are filled. Last one choice is enough. For this also we have 8 choices. So 8 into 8 into 8 into 8. Simply this is 8 power 4. We already have the formula n to the power of r plus 1 by 2. If r is r. So then also we can get the same thing. R is equal to 7. 7 plus 1 is 8. 8 by 2 in the sense here. 4. This is 8 power 4. Either by using the formulas or directly we can solve the problem. The last question. Third one. What is given here? Find the number of 7-digited palindromes. 7-digited. So we can take 1, 2, 3, 4, 5, 6, 7. 7-digited palindromes that can be formed using 1, 2, 3, 4, 5. We already know when the places are dominated, it will be places will become n. And the fill up the terms and the decrease and less, then it will become here r. Okay, that is the thing. Now 7 digit in the sense. So if you substitute 0 here, it will become 6 digit number. So that's why never fill up 0 in this first position. How many choices are there? Excluding 0, 1, 2, 3, 4. So we can fill up this one 4 times. So then automatically it is also filled here. Is it clear now? Now for this place, fine. Why? Because 0 may be present here. Only if it is present in the first place, it will become the 6 digit. So 0 will be filled here. So that's why we can have 5 choices. Then automatically this will be filled. For this also 5 choices. Automatically this will be filled. And for this also automatically 5 choices are there. So how much here? 4 into 5 into 5 into 5. This is nothing but 4 into 5 cube. Is it clear? Actually, if 0 is not there, we can get 5 power 4. 5 into 5 into 5. But if you take 0 here, it is not the 7 digit number. That's why only we took a 4 digit number like this here. So that's why 4 into 5 cube times we can fill up. So very, very important problem. For the annual exam, we may expect these palindromes questions. Okay, thank you very much.